For most of human history, the sky above us was silent. No radio signals. No artificial transmissions. No invisible waves carrying voices across the planet. But that changed in the 20th century. As radio technology expanded, the air around Earth filled with signals. Military communications. Navigation systems. Radar. Broadcast transmissions. Invisible patterns of energy moving constantly through the atmosphere. Most of these signals were deliberate. But some appeared unexpectedly. Especially after nuclear weapons were tested. During the early years of nuclear experimentation, scientists noticed something strange. Immediately after certain detonations, instruments around the world began detecting unusual radio phenomena. Signals where there had been none before. Interference patterns that moved across the spectrum. Echoes that bounced through the atmosphere in ways scientists didn't fully understand. These transmissions sometimes lasted seconds, sometimes minutes, and sometimes they created disturbances in the atmosphere that continued for days. Tonight, we're examining real historical cases where nuclear detonations produced strange radio phenomena. Signals that were detected across continents. Signals that briefly transformed Earth's atmosphere into something entirely different. And signals that revealed just how deeply nuclear explosions can disturb the invisible systems surrounding our planet. Why nuclear tests affect radio? Before we look at specific events, we need to understand why nuclear detonations affect radio signals in the first place. High above Earth's surface is a region called the ionosphere. This layer of the atmosphere is filled with electrically charged particles created by solar radiation. Those charged particles interact with radio waves. In fact, long-distance radio communication relies on this phenomenon. Certain radio frequencies can bounce off the ionosphere and travel thousands of miles beyond the horizon. For decades, military communication systems relied heavily on this property, but nuclear explosions can temporarily disrupt the ionosphere in dramatic ways. When a nuclear device detonates, it releases enormous bursts of gamma radiation, X-rays, charged particles. These emissions can ionize huge sections of the upper atmosphere almost instantly. When that happens, the structure of the ionosphere changes. And when the ionosphere changes, radio signals behave differently. They may reflect in new directions. They may amplify unexpectedly. Or they may disappear entirely. This is why nuclear testing often created strange radio effects detected far from the actual explosion. Story 1. Starfish Prime. In July of 1962, the United States conducted one of the most extraordinary nuclear experiments ever attempted. The test was called Starfish Prime. Unlike earlier nuclear tests, Starfish Prime did not detonate near the ground. Instead, the weapon was launched into space. At an altitude of roughly 400 kilometers above the Pacific Ocean, the device detonated with a yield of approximately 1.4 megatons. What happened next stunned scientists. The explosion produced a massive electromagnetic pulse. Streetlights in Hawaii, over 1,400 kilometers away, suddenly failed, telephone systems were disrupted, radio communications flickered and vanished across parts of the Pacific, but the most surprising effects were detected in the upper atmosphere. The explosion injected enormous numbers of charged particles into Earth's magnetic field. These particles became trapped. For weeks, they formed artificial radiation belts around the planet. Satellites traveling through these belts experienced severe damage. several early satellites stopped functioning entirely. Meanwhile, radio monitoring stations began detecting unusual signal behavior. Operators reported strange reflections, unexpected propagation paths, and bursts of radio interference that appeared long after the explosion itself had ended. For a brief period of time, the structure of Earth's ionosphere had been altered by a nuclear detonation, and that meant the radio environment surrounding our planet had changed as well. Story 2: Soviet high-altitude tests. The United States was not alone in exploring these effects. During the early 1960s, the Soviet Union conducted its own high-altitude nuclear experiments. These detonations were part of a series known as Soviet Project K nuclear tests. One of the most powerful tests occurred over Kazakhstan. When the device detonated high in the atmosphere, it produced massive electromagnetic disturbances. Power lines hundreds of miles long experienced voltage surges, electrical fires were reported, communication systems malfunctioned, but once again, radio monitoring stations recorded something even more unusual. Across large portions of the shortwave spectrum, operators detected powerful bursts of radio noise. These signals appeared suddenly, then faded just as quickly. Scientists later determined that gamma radiation from the explosion had interacted with the atmosphere to create intense electromagnetic pulses. But at the time, the signals appeared mysterious. Entire frequency bands erupted with static. Operators listening thousands of miles away suddenly heard explosive bursts of noise across their receivers. Signals that seemed to arrive from nowhere. Story 3: Operation Argus. In 1958, another experiment explored an even stranger idea. Could nuclear explosions in space be used to manipulate Earth's magnetic environment? This experiment was called Operation Argus. During Operation Argus, several nuclear devices were detonated in the upper atmosphere over the South Atlantic. The goal was to test whether artificial radiation belts could be created, and they were, but these experiments also produced unexpected electromagnetic effects. Scientists monitoring radio signals began detecting strange audio patterns within very low frequency transmissions. These sounds were unlike typical radio noise. Instead, they resembled whistles, chirps, and rising electronic tones. Researchers later identified these signals as interactions between charged particles and Earth's magnetic field, but at the time, the sounds were deeply unusual. Some radio operators described them as sounding like electronic birds, others compared them to distant sirens moving through the atmosphere. In reality, nuclear tests had briefly created entirely new electromagnetic conditions around Earth, and those conditions produced signals never heard before. Story 4: The Veilleur Incident. By the late 1970s, nuclear test monitoring had become highly sophisticated. The United States deployed satellites designed to detect nuclear detonations anywhere on Earth. These satellites were called the Veilleur satellites, and in 1979, one of them recorded something unusual. The event became known as the Veilleur Incident. The satellite detected a distinctive double flash of light over the South Atlantic. This pattern had previously been associated with nuclear detonations. At the same time, instruments on board the satellite detected electromagnetic signatures consistent with a nuclear explosion, but no country admitted conducting a test, and no physical debris was ever recovered. To this day, the event remains controversial. Some scientists believe it was a secret nuclear test, others argue it may have been a meteor impact or sensor malfunction. but the signal pattern detected by the satellite still closely resembles nuclear detonation signatures, meaning that if a nuclear test did occur, the only evidence that remains may be the electromagnetic signals it produced in space. Nuclear test monitoring today. After decades of nuclear testing, the world eventually moved toward international monitoring systems designed to detect any future detonations. One of the most sophisticated networks ever created is operated by Comprehensive Nuclear Test Ban Treaty Organization. The system uses hundreds of sensors around the globe. These sensors monitor seismic activity, infrasound, hydroacoustic signals, radioactive particles, but they also rely on electromagnetic monitoring, because nuclear detonations don't just produce explosions, they produce signals, signals that travel through the atmosphere, signals that move through the oceans, signals that ripple through Earth's magnetic field, and those signals can be detected even when the explosion itself is hidden. Every nuclear explosion ever conducted on Earth left more than a crater or a flash of light. It left a signal, a disturbance in the invisible electromagnetic systems surrounding our planet. Some lasted only milliseconds, others reshaped the ionosphere for hours, and a few created effects scientists are still studying decades later, which means that somewhere in the records of radio monitoring stations, in satellite telemetry archives, and in scientific datasets around the world, the echoes of those explosions are still preserved, invisible transmissions that once rippled through the atmosphere, long after the flash of the detonation faded.